Today we're going to be doing Mops, or lesser known as multiple operations. This is a very easy to understand, very easy to put into practice. It adds a lot of variation to the game, as it gives you a vastly higher number of operation signs. It can help you a lot, but since it adds so much variation, if you can't keep track of it, then you might get cooked by it. So basically, multiple operation says that any operation, power, root, factorial, number of factors, all of our operation signs, either from variations or regular gameplay, we can use them as many times as we want using only one key. So this plus sign could equal 3 plus signs. Basically, an example of this was, let's say we have our beautiful gold mat, and in it we have required and permitted and forbidden. Let's say we had a 2 in here, a 3 in here, 2 in here, a plus sign. And let's say our goal equaled 7. Multiple operations was called, you could say, oh, challenge now. Because I can use that plus sign as many times as I want, I can turn it into 2 plus signs. So basically, I write my solution as 2 plus 2, and then I get a free infinite amount of plus signs from multiple operations. I can use one of them, and I can stick the 3 in, 7. Does not need to be indicated that multiple operations is used. You just write it as a normal plus sign. Pretty basic, pretty easy. Now we're going to get into some multiple operations tricks that should be done. Today is the second day of multiple operations with variations. So what we're going to go over today is base numbers, the zero wild conundrum, and the funny root trick, which everybody loves. So a lot of people will be like, oh, base 12 is called base 12. And I know that the power equals 10 and the root can equal 11, but since they're both operation signs and multiple operations is called, can I use the root as infinite amounts of 11s and just have like forever and ever? No! You're not allowed to use multiple operations with these as numbers. Let's say you did have 3 roots and you want it to be like you could have this, and this could be a square root. Like if you had 3 roots, you could do square root like that, and that would be okay if you had 3 square roots. Just leave one over. You cannot use multiple operations to give you infinite 10s and 11s in base 12, or infinite 10s in base 11. Don't do that. Alright, the next thing we're going to go over is the zero wild conundrum. You'll be like, oh, zero wild's called, 0 can equal power root times division plus minus, all that good stuff. Well, basically, if 0 equals an operation, can I use that operation an infinite number of times? It's really disgusting, but yes, you can do that. So I could, if I had, let's say, 1, 0, and I had, like another thing, 2, 3, 2, and we're trying to get the goal of 7, I could say 0 equals a plus sign, and 20302 equals 7. Very gross. A lot of people don't actually know this. but so it can be used for some funny things. Someone will definitely call a judge over you, but the rulebook does say that you can do this, so that's nice. Favorite trick. So this is very common. Well, not entirely common, but it's a very good, like, fast play to use multiple operations for a funny trick. So let's say you have someone sets the goal as the 64th root of 3, and all you have in resources is like 1 root. You got a 3, minus, a plus, and like a 2. That's terrible. I can't make 64 out of that. What do I do? Do I challenge the possible? No, you don't, because multiple operations is called, so I can use that square root as many times until it equals 64. So, because roots, as we know, are equal to like the 1/2 power, I can multiply 1/2 times itself, but technically like 2 to the power. So whatever power of 2 equals this number, that will be how many roots I have. So we know that 2 to the 6th is equal to 64. So 5 square roots, 6 square roots, is equal to the 64th root. So my solution would be the 64th root of 3, root, 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 root 3. And this would be a 2-cube solution, so it can be used to rush people. A lot of people don't know about this for some unknown reason, and it's very, very fun to pull off and satisfaction.
Okay, so we already covered Mops in the last video, so now we're gonna see how it combines with other variations. So, as we know, Mops is multiple operations. So let's first see like what variations it can combine with. So there's two variations that give you new operations. They are namely factorial and number of factors. And there's other things as well. We'll cover this later. But so as you know, with factorial, you can use a maximum of 2 everywhere. You could put 2 in your goal, 1 in your solution, and 1 in your goal, or just 2 in your solution. That's what regular factorial allows you to do. You can also only use 1 or just not use any at all. But when you have Mops, you're allowed to spam factorials in your solution. But in your goal, you're still only limited to 2 factorials. So for example, you could write something really funny, like, I need to solve for 2. So you could be a joker and write the amazing solution with Mops and factorial called as 1 factorial 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 plus 1 factorial 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 is equal to 2 factorial factorial.
Don't do this.
Yeah, you shouldn't do that, but like it's funny. That's like one example. There are more like useful examples, but this is something you could do. So this is something Daniel Robertson when he was playing Reese. So it's funny, you can do it. It's just not very useful usually. However, with number of factors in Mops gets a lot more feasible. So I'm gonna go over something that's a bit weird. Just follow along with me. This is a bit unmotivated. So let's say you're finding like x of n, where n is just some arbitrary number. Now the thing is, not every number that's less than n will divide n. Right, unless n is 2. We don't talk about 2. 2 is like weird, anomaly. Otherwise, okay, so let's say n is greater than 2. So if n is greater than 2, then n minus 1 does not divide n. This means that out of the n numbers that are less than n, one of them is not a divisor. So this means that x of n is less than or equal to n minus 1. Now, there are better bounds on this. A much better bound is x of n is less than or equal to 2 times the square root of n. But proving this is left to you guys. I can do it, but I'm not. So we're going to stick with this here. So what does this mean per se? Well, let's say someone... So x of n is less than s to 1 while n is greater than 2. Once n hits 2, x of 2 is 2, so it's just the same thing. So something you could do with this is, let's say someone sets the goal as 2. And your only cubes, so I'm going to draw another math. So let's say a goal is this 2. Goal is 2. And required, we have an 8, a power sign, and a 9. And resources, we have an X, a power sign, and yeah, sure. That's all we have. I don't know what the other cubes, but they're just gone. I ate them all. So, and let's say we have mobs and number of factors called. You could challenge now. You might be asking, okay, how do I challenge now? Well, I just showed that x of n is less than or equal to n minus 1. So if you were to say this, x of 8 to the 9, where you apply x 8 to the 9 times, wouldn't this quantity just eventually reach 2? So basically the point is, if you apply x or number of factors to a number enough, it will reach 2, no matter what. As long as it's not like 1, x of 1 is 1, but if it's a number greater than 2, applying x enough times will make it reach 1. In general, the trick is, if you want x of n to become 2, you just apply x n times. So there are much better bounds on this, but that's up to you guys. You may see a proof in later videos.